to episode 7 of AI for Humans. Last week, we were able to identify a very simple concept in the AI flow, and that was the report card for AI, where we explained that for every decision that the systems make during training, when we teach a machine to know the difference between a cat and a dog, to know the difference between the house prices on the mainland and on the island, we are teaching it with examples. And so it learns from the examples by patterns and not overfitting. If you watched episode 5, you would have remembered what we talked about overfitting. It's not cramming the answers, it's understanding the patterns between them. And then using those patterns, it predicts the results, and then we score the results. If the result is correct, we tell it correct. If the result is wrong, we tell it is wrong. AI's report card. At the end of the last class, we were able to identify how the report card system works and why it is actually very worthy. However, in machine learning, we don't always have the answers. Let's put it that way. You see, everything we've considered so far assumed one thing, that we always have the answers. However, this is not always the case. Sometimes we don't have the answers. See, sometimes we tell the AI, this is a cat, this is a spam message, this house is worth 80 million. True. Other times, we don't. What if we had a pile of data and we do not have any solutions? We just want to feed it to the machine and help it to figure out the answers. That's actually unsupervised learning. And that's going to be the core of what we'll discuss today. Very excited about this because one, this is one of the most intelligent things in machine learning. That's number one. And number two is that it's a concept I'm very excited about because I like the way it works. So let me give you a very good example. You see, I remember when I was in GSS1, when you are introduced to the schooling system, and you're probably showing your class for the first time, then you're asked, okay, find your seats. You'd see that students would be arranged in, sorry about that. No. Will be arranged in a class, right? Now, this can give you a very brief understanding of what unsupervised learning is and how it works. Now, we were brought from different primary schools, so I remember then I had 4 of my friends. One of them was Favor, there's Chinemelum, there's Shegun, and there was me. There was me, and there was 4 of us. We all came from St. Saviour's Primary School, right? And we're going into high school. And there were some other people like maybe like Modupe, Tunde, I don't know these people, and then Ola. And let's say these people came from another primary school in my area, then let's call this school Eagles. And then let's say we had Tolani and Bolaji, and these ones came from Durable. But then we had a few other students, let's call them X, Y, Z. This is a very messy table. And these guys came from other schools, right? We don't know their schools, but they came from other schools. Now, you see, when you get into the class, you'd find out that the shares are arranged in rows, right? Everyone has a row. Now, let's imagine that everyone here did not come from the same school. Let's imagine that Favor, Biodun, Chinemelum, everyone came from a completely different school. We do not know each other. We've never met ourselves before. And then in this case, the teacher did not tell Favor, sit here, and did not tell Biodun, sit here, sit with this person. The teacher just says, all of you go to your class. Let's call this class. And this holds no value anyways, but let's just call it GSS 1A. So they are told all of them should go to class. When they get to class, there's something that is very common with human biology. When we talk about evolving species, it's termed natural selection. And it is a very interesting thing about humans, is that when you come to the class, you would find out that maybe on the first day, people will sit randomly, right? On the first day, you would find Favor sit here, Chinemelum sit here, Biodu will sit here, Matthew sits here, Timothy here, Oye, and Tolani here, Bolaji here. Everybody sits quite differently. But over time, there's going to be a quiet difference. And the difference is you might just find out that after a week, the seating arrangement changes. And you will notice that somebody has moved. Probably Favor has moved here. This guy has moved here. This person moved here. And I'd most likely move to middle seat. I hated the front seat. Most people would have made movements and clusters will be formed. And what are those clusters that will be formed? Those clusters that will be formed are, you will notice that, let's use a Venn diagram to describe this, right? You would notice that from this class, right, you notice that people who like to study would probably start sitting together. Then people who like to make noise, you notice that they start sitting together. Then people who like music, they will probably start sitting together. You'd notice that like similar interests make people sit together. And then sometimes you might find that there are some people who like noise and who like music as well. They sit in the middle, right? They are floating between these points, and the same could happen here and the same could happen here. I'm getting so much into the math. What I'm explaining here is similarity pulled everyone together. Similarity pulled the studious guys. Similarity pulled the noisy guys. Similarity pulled the musical guys together. This is exactly what is done in unsupervised learning. So in unsupervised learning, it's like we are giving the machine, it's like we give the machine data without labels. So we say, this is a boy, this is a girl, this is a name, all of this data. Now remember that we said earlier, and think of it like this. Remember we said earlier that we can give the machine examples, and this was in episode 5, where we say we can give machine 9 times 1 and we tell it is 9, 9 times 2 and we tell it is 18, right? And we can continue in that format up until we get to 9 times 12, right? We give the machine the answer. Here we are giving it the question and we are giving it the answers. However, here we are giving it the questions without giving it the answers. So let me give you a very good intuition here as to how this would work. And this is not, once again, we give a lot of examples. In the code, it's quite different, but you just want to get the idea, okay? And I want to see if you can catch the similarity here and see if you can think like a machine. And obviously, you're smarter than a machine, all right? And the machine just has more compute and more attention span. So think of it like this. Imagine if we told the machine sorry about that, can be acting up lately. See, machine is very unreliable. So imagine we told the machine 3 times 1, right? That's the first set of data we give the machine, but we did not give the machine we didn't give it an answer. We say 2 times 4. Once again, but no answer. We say 3 times 9, and we say 4 times 4. Now, you watching this video right now, can you find a similarity? Yes, you can. You did not even calculate it. You're just looking at what is similar. So you most likely have tagged this one, 3 times 1 and 3 times 9 as similar, and you've tagged 2 times 4 and 2 times 4 as similar. Now, let me tell you what you are doing here. What you're doing is that you're looking at a concept you already know, which is odd numbers, even numbers. That's what you're doing, ideally, right? You found a similarity and you've clustered it. So in this case, machines will look for similarities in the way the examples are given, even if there are no answers given, and it will cluster like that. Let us use some real-world examples to be able to identify this. And I'll use a few things that we're very familiar with so that you'd see that machines don't really know. When we say they are smart, they're not smart, but they are very good at catching patterns in the data. So let me give you and this is something I actually work with a lot. So once again, I'm very excited because I believe we've not even touched base on what machines can do in this aspect of unsupervised learning. But it's a very interesting part of machine learning. So let's use Spotify as an example. Have you ever noticed that whenever you're using Spotify, you're listening to a song on shuffle. You're not intentionally picking a playlist. You just go, you search for a song, you listen to that song, and then the next song that you're listening to is a song that it resonates with you. You're like, oh yeah, I like this song. And for the next 5, 10, 15 minutes, all the songs that keep coming to your playlist are songs that you enjoy. How do you think Spotify is finding that? It's machine learning. So you see, for every previous Spotify user, one thing they would have done is, let's imagine you're using Spotify for 3 years, right? Every time you played Afrobeats, right? Spotify has something called, well, all machine learning systems have something they call the similarity score. Every time you played Afrobeats, if they would suggest, so they would already suggest a song. Let's imagine you're a new user. The first time you're using Spotify, you selected an Afrobeat song, then they will say, okay, since you like Afrobeat, let us suggest blues, which is weird, but I mean, in this example, let's suggest blues. And then immediately you hear the blues, you skip, you just skip it. And then they say, oh, okay, let us suggest R&B. And then you listen to this song up until like 2 minutes out of the 3 minutes, and then they say, okay, let us suggest Afro pop. And then you skip it again. And they say, okay, let us suggest what other genre of music is there? Country. Oh, I like country. Country music. And you listen to country music to the end. The next time, you're going to try another set of examples, another set of data for you. Remember, you're a new user, they don't know anything about you. But one thing we can tell so far is that you most likely enjoy Afrobeats. Most likely, we will not do it based on intuition. You enjoy Afrobeats, you enjoy R&B, you enjoy country music. Okay. Now, let's be sure that this person actually enjoys it. The next time you come to the app, you search for Afrobeats again. Afrobeats. Now, remember, it is like having points on the Premier League table. Afrobeats now has 2 points. And I promise you, this is something you would enjoy. Afrobeats. And then we say, okay, let's try to select blues again. And this time, you say no. And then we give you R&B, and then you listen. And then we give you Afro pop. But you don't go to the next song. You listen to it, and then we give you country. We listen to it. Ideally, what we'll do is next time we will not suggest blues to you again because we believe you do not enjoy blues. What we've done is we found similarity. Similarity in the type of music you enjoy versus the type of music that you do not enjoy. Now, imagine doing this with you over 1,000 times. We know the type of music that you like. Remember, when you came to Spotify, they most likely don't ask you, what type of music do you like? I mean, I don't know how the app works now, but I don't remember them asking me, do you like this type of music? Do you like this artist? Do you like this type of music? No, they don't. Now, let me make this a bit more interesting. Let's imagine, I don't know if this is how their algorithm works, but it would be really nice if they actually implemented this. Let's imagine that every time we suggested Afrobeats in the morning, you listen to it. And this would be so intelligent. Imagine every time we suggested Afrobeats in the morning, you listen to it, but if we suggest Afrobeats in the afternoon, you skip. What does that mean? It means you are more of a morning person with Afrobeats than an afternoon person. Now, that's by the way, that's not important. But let's move to the next thing. Now, another thing that we'll do is for us to be able to understand you. Now, you might ask, why did Spotify suggest blues to me after Afrobeats the first time I actually listened to it? It is because there is a tendency that Spotify in its data let's say Spotify has 40,000 users in your location, 40,000 users in Lagos, right? And once again, this is not how Spotify works. I'm just giving you intuition so that they don't sue me. So imagine Spotify has 40,000 users in Lagos. Now, if out of these 40,000 users, 25,000 of them live on the mainland, right? And these 25,000 of them love to listen to Afrobeats and blues. if you, the new user X, should log in and create an account on Spotify from the mainland, remember, all of these users did not tell Spotify, I like this or I like this. Spotify learned it from their data, similarity. We would now automatically apply a similarity score of mainland suggests Afrobeats and blues. Just give you intuition as to how some of the applications work. So whenever you see some suggestions, even on your Instagram, right? And which is a very good one, because even on your Instagram, you notice that some people say, oh, my algorithm is messing up. It's not. It's actually studying a lot of things. There are so many factors involved. But the moment you go on Instagram and they show you a food video, you like it. They show you a bike video, you don't watch it, you skip it. And you do this over and over and over again, they tend to show you more food videos. Why? Similarity. They're looking at what are the things that you enjoy and they show it to you. So you can already see that unsupervised learning systems are already working in the main world as it is today. So many things work on this kind of systems. We simply feed the data to the machine. We can, maybe the bank, imagine Access Bank, they could have 20 billion rows of user transactions, right? We just feed all that data to the machine and we say, learn the patterns in all of that. So think of any application you use. I mean any application you use, right? Think of your Netflix. How does Netflix know which movies to suggest to you? Sometimes they use your neighborhood. Everyone around you who is watching Netflix, which is why you should not share passwords. Everyone around you is watching Netflix and they say, okay, if everybody in Nigeria is watching Black Panther, it's all right. If you are a new user of Netflix and you come online, they will just automatically suggest Black Panther to you because that's what everyone else is watching. Similarity. It does not have the answers, so it has to look for what is similar in data. What clusters you with a set of users? It happens on places like what? Jumia too. This is why you realize that the data that is being shown to you, this is why if you and your cousin should log in on Instagram or TikTok at the same time, the data she's being shown is different from the data you are being shown. Why? Because the similarity scores are not the same. Everybody has a cluster that they belong to. So how would Instagram cluster it? Instagram might say cluster number 1, foodies. Why? These people always like food videos. Cluster number 2, challenge. These people are always looking for the next dance challenge. Those are the kind of things they like to watch. Cluster number 3, AI. These are people that are always watching AI videos on Instagram. So this gives you the idea. Now, let us break it down all together. What is the difference between supervised learning, which is what we learned last week, where the machine has data, the machine is given a report card, and unsupervised learning? Let's break that down. So, supervised, unsupervised. What does it mean for it to be supervised? In supervised learning, you have a teacher, right? Remember, you have a teacher and you have data that has answers, right? So here your data has answers. The machine knows how to match inputs and outputs, and it is good for detecting such situations. So the machine already knows the outputs, and then it matches the outputs with the inputs. That's number 1. Number 2 is that the machine is then tested. After we've given it all of the data and the answers, then we ask the machine, how well did you understand the data that we gave you? And then the machine will look through it and say, oh, I understand. And it will give us an answer. We'll check the answer with the original answer. We are grading it. However, in unsupervised learning, there is no teacher. Nobody's teaching the machine anything. What do? We just pour all the data in there, and then the machine would find structure. So the machine would find structure or similarity on its own. All of this data have been given. What are the patterns in there that I can find that nobody else can actually find? What are some connections between the data that I can find that no one else can find? Now, this is the interesting part. A very common question that most of my friends would ask me is supervised or unsupervised learning, which one is better? And I think, I think none of them is actually better than the other. We just have different use cases, right? In cases where we know that user data is just going to keep increasing and we cannot label everything, we cannot give the answers to everything, unsupervised learning is better. And one thing, the reason why I really like unsupervised learning is it can expose patterns that you would not ideally see in the data. Very interesting part about unsupervised learning. So, what have we learned so far? Give machines a lot of data and they will figure out the patterns in it, right? And this is actually, once again, something I'm very excited about machine learning because I believe we have not even scratched the surface of unsupervised learning. This is intuition and this is not the code. This is not the math. There's a lot of mathematics involved. There's a lot of Python code involved in this, which we're not going to go into. But I believe you understand what unsupervised learning is and you can talk about it like ideally anyway as to explaining what it means for a machine to go through unsupervised learning. Next episode, we're going to talk about a completely new ingredient. And this is how, remember, I don't know if you ever read in the news when they said AI actually beats the best chess player in the world. What if every time AI got the answer correct, what if we give AI, every time AI got the answer correct, we scored it. We said good for getting it correct and bad for incorrect. This is the next part we're going to go. And this is what we call reinforcement learning. Reinforcement learning. So, next episode, come and understand why AI is so good at solving mathematics, why AI is so good at beating chess players, why AI is so good at playing games. This is something we call reinforcement learning. And next week, we're going to be able to understand what it means for us to reinforce the answers that AI has given us so that it can become perfect or close to perfect at any of this. See you on episode 8.